When I say silly, what's the first image that pops into your head? Talking dogs? A Dr. Seuss book? What about a saint? Canonized by the Pope and all that. Today, that seems like a weird thing to say, but were you to go back in time, say to the early Middle Ages, saying that a saint was silly probably wouldn't have earned you an excommunication. Why? Because compared to what it means today, back then the word meant something very different. Blessed. Over time, it slowly changed meaning, going from the sacred to the comical. This process is known as semantic change, and it's pretty common actually. Through time, words are used by different people until they eventually represent seemingly unrelated concepts. I bring this up not because I think everyone is as fascinated with linguistic trends as I am, but because I think it can provide an important perspective. We tend to have certain concrete ideas about what things are, and about how the words we use to describe those things are static and unchanging. Take for instance the computer. I'm going to go out on a limb here and say that your computer is probably a box of metal and plastic, and it probably has a screen. It may or may not have a keyboard. Some of you may be watching this video on your laptops, or your desktops, or even your mobile phone. And if we look around, this seems like a pretty good definition. Lots of computers, or what we seem to think of as computers, have all of these features. But what about this? It doesn't have a screen or a keyboard or aluminum. It doesn't have a hard drive or a processor. Heck, it doesn't even run on electricity. But I'll tell you what it does have. Gears. Right, so this is called the Antikythera mechanism. It was made in Greece over 2200 years ago, and although it doesn't have any of the hardware or software that we associate with computers today, it calculated with relative accuracy the positions of planets and the dates of eclipses. Now, there are several differences between something like the Antikythera mechanism and the computer sitting on my desk. The first is pretty obvious. The Antikythera mechanism doesn't run on electricity, it's mechanical. The second difference is related, but not quite the same thing. The Antikythera mechanism is an analog device, and pretty much all modern computers are digital. Usually we hear analog and digital refer to different types of watches, or a record versus a CD, but in all of these cases, analog doesn't mean old. Analog and digital refer to the differences between continuous and discrete sets of information. Analog signals are continuous. They can exist for an infinite or near infinite set of possible values. Discrete signals, on the other hand, can only exist on certain predefined intervals. This idea of data existing at some values but not at others is a really important part of how modern computers store information. Binary data is made up of only ones and zeros, but not any of the values in between. For a long time, most computers were analog, and when the first digital computers became available, they were clunky and unwieldy, primarily because they relied on vacuum tubes to function. These were easily breakable and generated lots of heat when used. The breakthrough for digital computing came with the invention of the transistor, a tiny electrical component which is fundamental to the operation of computers today. Transistors work like tiny switches, manipulating electricity into on or off states. These become the ones and zeros of binary. The number of transistors a computer has is basically a benchmark for how computationally powerful a computer is. Early transistor computers had a few hundred, and today there are billions in every computer and smartphone on the planet. The density of transistors on an integrated circuit has risen astonishingly fast in the past few decades, a fact noticed by Gordon Moore, one of the founders of Intel. In what became known as Moore's Law, he postulated that the number of transistors on an integrated circuit doubles roughly once every 2 years. This is why computers get better and better each year, and why they go out of date so quickly. Each new processor has that many more transistors on it than the one that came out last year. It's unlikely that Moore's Law can continue forever, because you can only make transistors so small before they stop becoming functional. Today there are lots of different brands of computers, but they're all pretty much built with the same pieces. First is the Central Processing Unit, or CPU. It's kind of like the core of the computer, performing all of the calculations necessary for a computer to function. Now, the power of a processor is usually measured in its ability to compute mathematical operations on floating point numbers, basically just numbers with a decimal point in them. This leads to possibly the greatest named unit in history, floating point operations per second, or flops. Then there's storage. If you think of storage as how large your hard drive is, the more storage your computer has, the more data and documents it can hold. Next is random access memory, or RAM. This is usually just called memory, and it stores data about currently running software on your computer. When you run a program, that data is copied from storage and placed into RAM. Now, a lot of people think that having more RAM means a faster computer, and that's partially true, but your computer speed is also dependent on all of the other parts that the computer has. And just to be clear, you cannot download more RAM. Memory also comes in much smaller increments than storage. It's not unusual for a computer to come with over 500 gigabytes of storage, but only 8 gigabytes of RAM. The final parts of a computer are input and output devices, usually called peripherals. Input devices, like keyboards and mice, allow you to give data to your computer, and output devices, like speakers and screens, give data back. In addition to all of the physical components of a computer, there's also the software, the programs and instructions that run on the computer that make it more than just an expensive piece of plastic and metal. If you think of a computer's hardware as an instrument, then the software is the sheet music that an instrument can play. For next week, consider how computers have changed throughout history. Think about the technologies which have helped shape where computer science is today and what technologies might be developed in the future. Also think about how people have imagined the future of computer science, as many science fiction authors have. Which of their predictions have held true and which haven't? Next time, we're going to talk more about transistors, binary logic, and why 1 plus 1 actually equals 10. Thanks to all of the people and sources who have helped make this content available for everyone for free. To find more free resources, lesson plans, and other videos, check out our website and our GitHub account.